Yeah, so welcome everyone. This is our 25th Northeast Digestion Roundtable. It's our silver anniversary, Brendan. Northeast Biosolids and Residuals Association has been hosting these and sponsoring these sessions since April 2016 to share technical and operations experiences and advance best practices for anaerobic digestion. And it's really not a webinar, it's more of a meeting or a round table, so pretty informal. We're going to have a presentation today, and then we'll open it up for questions and discussions. And I know the presenters value the feedback they get from all of you who design, operate, and permit these anaerobic digesters. So if you could just mute yourself for now, we can open it up for questions and discussions later. There's also a chat function at the bottom. If you have any questions, you can throw them in there. I'll be monitoring that. So type them in as they come to you. So as you can see, our topic today is nutrient recovery, and specifically using superfiltration membranes to enable nutrient recovery in digestate. I think you're going to find this very interesting, and it's a very important topic. I hope you agree. A little bit more about our presenter today. First of all, ZwitterCo is a NEDR member, and Brendan and I go way back from when he was very active in NUIA. But Brendan Curran, he graduated from Northeastern University in 2019 with a degree in chemical engineering. He did spend a few years working at Stantec in the municipal water and wastewater treatment design section before transitioning into his current role as sales engineer at ZwitterCo. And in that role, he focuses on working with end users and process development engineers to implement the membranes in liquid digestate treatment projects. As I said, this is intended to be more of a meeting or a roundtable, so we definitely want to leave some time at the end and open it up to questions. So save all your questions or put them in the chat, and we'll do that after. We are recording this. It'll be available after the fact, so no need to take extensive notes. And with that, I'll have Brendan go ahead and take over.
Thanks for the introduction, Janine. Like Janine said, I've known Janine for a few years. I was part of the Contaminants of Emerging Concern Committee, and I think that's when I first got interested in membranes, and then that's when I switched over to, right around then is when I switched to working at ZwitterCo, so from Stantec. So today I'm going to talk to you about ZwitterCo superfiltration membranes, and specifically what they're capable of and what kind of processes they're using for nutrient recovery and digestate applications. We work in food waste digestate, industrial food waste digestate. We've done some sewer separated organics digestate testing, and most of our applications right now are in agricultural digestate from cow manure, swine manure, chicken litter, and those type of projects. So we'll get a little bit into that and why ZwitterCo has been used in some of these applications and why it's important for digestate treatment and why it's coming about in the current market. So click through. This is just a little background on the company. So ZwitterCo is a startup. We were founded in 2018. It's a technology that came out of Tufts. The reason that we're called ZwitterCo is because of Zwitter ions that are used on our membrane. So a lot of people think that it's like Twitter, but it's because of the Zwitter ions. So currently, after 5 years, we've have over 4 million gallons per day in treatment capacity delivered. We've booked 20 commercial projects. A decent amount of them are digestate. Digestate is one of our core markets. So we have some other markets, but digestate is one of our biggest markets. And we've gone through Series A funding, which is where most of our funding money is coming from right now. And we've raised over $46 million so far for all of our seed funding, Series A funding, and some other grants that we had. We're based in Woburn, Massachusetts. We are a member of NEBRA as of last year. So that is exciting. And we have our innovation center. We were in Cambridge before, but we were part of Greentown Labs at one point, and then we moved to Woburn to build our own manufacturing capabilities out there. So we have a bigger space out there, and that's where the innovation center is, what we call it. The other thing, we just have a quote from CNBC has quoted us for last year for our ability to use our membranes for water reuse and wastewater recycling, specifically in like agricultural and industrial wastewaters. That's a little bit of the background of the company. And this is more specific to what I was talking about with the Zwitter ions. So what we are is we took the chemistry that came out of Tufts, the lab in Tufts, the self-assembling Zwitter ions, and we used that in our spiral wound membrane. And that is the reason that the membrane is so special, is because these Zwitter ions are extremely hydrophilic. So they're able to attract the water through the membrane, and then the organics are on the surface and they don't stick to the surface of the membrane. So it's an anti-fouling membrane. And that's one of the biggest reasons that we're in an application like Digestate, because Digestates have a ton of organics and a ton of foulants that can't really move forward to a reverse osmosis unless it can get the organics off the membrane or out of the stream before it goes to RO. So because of the Zwitter ions and the way they self-assemble on the for the active layer of the membrane, our membranes have an unprecedented ability to recover upon cleaning. So we just do simple cleanings with water flushes, caustic, bleach, sometimes an acid, and they're able to recover to full performance recovery on Digestate. And I have some data that I'll show you towards the end of this presentation about that. This is where ZwitterCo lies on the membrane spectrum. So superfiltration is a more new, kind of a newer term that has been used in the membrane world. Superfiltration is a class of membranes that's kind of between ultrafiltration and nanofiltration. It's a tight ultrafiltration with organic rejection that's similar to ultrafiltration, but it doesn't quite let as much of the salts through or excess nutrients through that nanofiltration would. So that is where ZwitterCo lies in the superfiltration membrane spectrum, meaning we have a molecular weight cutoff of about 1 kilodalton. We reject any TSS that's remaining in the stream, all the organics, but we don't reject any of the ammonia in the stream. And what we're really good at is basically taking everything out of the stream before it gets to RO. So that ammonia is in digestate applications is then going to get concentrated in the RO. Same with some other nutrients like potassium and the remaining salts. So we have a lower salt rejection than NF and a higher organic rejection than the UF. And that's really important for a stream like Digestate. This is a little bit about specifically ZwitterCo in Digestate applications. So the picture to the right is one of something that we did very early on. This actually happened before I started, like over 2.5 years ago now. And this is a picture of one of our runs that we did with manure digestate in our lab. And this was run through our membrane for a day, and then they just did a water flush and used caustic, and then they were able to get full performance recovery on the right side of the stream, which is really impressive for this membrane, because most membranes cannot handle that level of organics and then recover that well afterwards. So the way that the Zwitter ions self-assemble and the low fouling nature of the membrane, we've handled streams with over 50,000 ppm of fats, oils, and greases. So that's huge, especially in food waste digestate. That's a very big driving factor is why people are using these membranes before RO and like food waste digestate. There isn't as much fats, oils, and greases in manure digestate, but some of the streams do have a lot of fats, oils, and greases. And then we'll get the full performance recovery, like I've mentioned a few times, after the mild maintenance wash. In Digestate, we have like precision separation for discharge or reuse. So a lot of the projects that we work on, they're trying to reuse the water. Then they're also trying to discharge it. And then at the same time, they're also concentrating nutrient product. So the way that the process works is we'll be before a reverse osmosis. And we take out the remaining fats, oils, and greases, proteins, and suspended solids, and then that our permeate goes to the RO membrane. So we produce ideal feed water for RO because we're moving all those macrofoulants and remaining stuff that's in the stream. People have also considered using other downstream polishing steps, not necessarily reverse osmosis, but things that can't handle a lot of solids. So ammonia stripping, sometimes people use after us if they want to get more of the solids out of the stream. And they just want to focus on the permeate with all the ammonia in it, and other technologies like that as well. So this is going to be a quick background of the market for food and manure digestate and what we've realized and kind of how ZwitterCo fits into that and what the benefits of using membranes are in digestate applications. Like a lot of the legislation is kind of moving towards having nitrogen limits in digestate applications. Like there's a huge boom in biogas, which is why we're all here right now. So, but the one aspect that is coming about a lot more is that these biogas projects are turning into wastewater treatment projects. I've had people tell me that sometimes the biogas is the easier part right now, and then they have no idea what to do with their digestate after. They can't spread it on the land anymore. They have to figure out what to do with it. So that is why they're kind of coming to companies like us to figure out and help them with developing a process so that they can treat that digestate, get some valuable byproducts from it, and be able to reuse the water to help them even more. So I'm going to talk about 3 current options that people have to manage the digestate, and what the current option is, and then what is ZwitterCo enabled solution. Oops, that went fast. What a ZwitterCo enabled solution can allow in that space. So the first option is storage. So people have their anaerobic digesters. I'm not sure why this is going so fast. They have their anaerobic digesters, and then they take the digestate and they store it on site, either in a lagoon or I think there was something on the presentation that's going through, so I'm just going to let it happen.
All right. You could try going backwards.
It's happening right now.
Yeah, it's like it's almost on auto. Yeah, it's got some kind of a timing function on it. Can you
Let me
pause
stop
it
sharing
down
the
the
screen
bottom?
really quick and double check this.
All right, and we did actually have one question come in. Let me see what.
All right, let's see if we
what
can
that
answer
is.
that.
Sure.
Got this.
Yeah, Steve's looking at to see if you can talk about the impacts of water treatment chemicals, the impacts on membranes. So coagulants, flocculants, are they having any kind of impact?
Yeah, that's a great question, because a lot of these people are using polymers and other coagulants before, like in a solid liquid separation phase on the back end of their digester before it goes to a membrane system. Cationic polymers, specifically cationic polymers, are a no-go for a lot of membranes, and our membrane included. It's not necessarily the like the active layer of the membrane that will get impacted by that. It's the way that the membrane is configured that it gets impacted. So the spiral wound element. So the feed spacers, the cationic polymer sometimes gets stuck in the feed spacers. There hasn't been any issues with other coagulants.
And that's what we've seen too. We've with the VSEP and the cationic polymers, just they would not work.
Okay, so yeah, you're familiar with the VSEP, and it's similar. It's, cationic polymers aren't working with the membranes just because it just isn't working. So other people that are using other coagulants, I mean, normal coagulants are working. Any inorganic coagulants a lot of times is similar.
So Brendan, I could probably bring up what happened here?
Again, yeah, we can share the backup.
Yeah, hang on. Now my screen's acting funny. Yeah, let me pull that up.
I also was going to pull up the backup, so I'll just let you.
All right. Everything's just one of the problems with having these things at noon, it's like everybody's on the internet at lunchtime or something. It seems like I get. Yeah, I'm having problems pulling it up right now.
I'll pull it up.
All right. Yeah, my OneDrive's still trying to pull up.
One other question, Brendan.
Sure.
What about struvite?
Struvite? I haven't seen. Are you asking if we have issues with struvite?
Yeah, just is that an issue or in streams that struvite is a concern?
I haven't seen it.
Membranes.
I haven't seen it as an issue with our membrane right now. I would have to double check with the technical team. I haven't seen. I haven't been asked that a ton in Digestate yet, so that is a good question. But I can double check with you and get back with you on that one.
Still waiting for my OneDrive to pull up. Well, an error has occurred. Why don't you use the PDF, Brandon?
Yep, I'm pulling that up right now.
All right, that'll work.
I'm going to share that now.
Good problem solving.
Just
Thanks, Ryan. Yeah, we got it.
All right, here we go.
Sorry, hopefully that wasn't too painful. All right, back in action.
Okay, so back to the current management options. Seems like now that I've seen some of the questions, some of you are very familiar with what the current management options are, because you're using other membranes. So one of the current options is storage. So people are taking that digestate and storing it on their site. And this is especially a problem with urban food waste digesters, is that they don't have any ability to store it. A lot of the agricultural digesters, they have so much space that they can store it. But when there's limited space, the food waste digesters have to have another way to manage digestate. I've also been told that people have the overall farm's carbon intensity score has increased when they have to store the digestate, because that methane, even after the digester is releasing into the atmosphere, more carbon is releasing into the atmosphere, and their carbon intensity score is going to increase from that. So storage there is a problem as well. One of the things that ZwitterCo identified is that a ZwitterCo enabled solution, membrane enabled solution, reduces the storage needs because you're concentrating those fertilizers, generating the valuable byproducts, and then there's less volume of digestate to be stored. So there's less water because you could discharge the water, recycle the water, and then create the fertilizer product. Go forward. The other thing that is currently happening is starting to happen more and more in the US. A lot of times in other countries, this is like some of the only options that people have now, but offsite hauling of digestate. Whenever there's a project where people are hauling digestate offsite, it becomes extremely expensive just because fuel costs are going up, and people are having to haul farther and further away because the places right next to the farm or wherever they're spreading the digestate is now at its nutrient limit for that land. So then they have to find more land further away. So again, as ZwitterCo enabled solution, we've seen that it significantly limits offsite hauling by more than 50% in some cases, because we're just concentrating the products and removing allowing the water to be recycled and discharged instead of hauling that water off-site. This is a more typical, like when people have to treat digestate, a lot of times people are thinking of biological solutions, like an NEDR is especially common in Europe right now, and it's becoming also common in the US with new digestate projects, a lot of food waste digestate projects especially too. An NEDR, this is kind of comparative analysis of like an NEDR versus a spiral wound element, which would be a ZwitterCo plus RO membrane setup. An NEDR is a biological process, whereas a spiral wound ZwitterCo enabled solution is a physical separation process. The NEDR, the biological process is converting the nitrogen, and the spiral wound ZwitterCo enabled solution is concentrating that nitrogen instead. NEDRs are difficult to scale up when you put a tank in a space. You can't, if the flow rate is going to increase eventually, you have to build another tank or figure out how to make that tank bigger. Membranes are in a modular format, so they're able to be scaled up easily. Once you have a skid, you can put more membranes on that skid when you need to. Especially in urban areas, again, the large tanks have been causing issues with they don't have enough space to put the NEDRs. So the SF and RO solution is a smaller footprint. So that was just a comparative analysis of some of the current options, some of the common current options that people are using in the US, and why people are moving towards membranes there. This is a little bit more about, this is kind of an overview or a summary of what I just said as ZwitterCo and digestate. So we're the ideal pre-treatment to reverse osmosis for removing the organic foulants. We have better water quality for the RO so that there's less cleanings of the RO elements. There's a longer lifetime. Ideally, we want to decrease the OPEX and CAPEX that people have to spend on these digestate projects for agricultural and food waste digesters, because those are important. That's important for a lot of people. Spiral configuration is energy efficient. The way that the membrane is configured, most spirals can't handle the level of organics. So that is, if you have a spiral that can handle that level of organics and it's energy efficient, because we just use smaller pumps, less cross flow used in the membranes, then it's an energy efficient solution. And we help people achieve their sustainability goals with water reuse and recovering byproducts out of the digestate stream. This is a little, so the next I have a few slides on our commercial case study. So one of our largest projects now, it's now been running for 3 months. It's been in design phase for a long time, but it's running as of May 2023, it's been in operation. So this is a very large digester project in Wisconsin. It's called Brown County Organics. It's in Greenleaf, Wisconsin. It's a centralized digester operation that services 13 farms in that area. So there's 35,000 head of dairy cattle's manure going to that space. And this project was done by Dynamic Renewables, and the project is, the digestate portion of the project was done by Digestate Organics, and they were using our membranes in their process. So it's treating 1 million gallons per day of digestate at this facility. Some of the challenges that they were facing before is that they didn't have a solution for their digestate, and this is one of those projects that I was talking about, that the digestate or the digester project was turning into a wastewater treatment project. They were looking at other options of what to do with the digestate that weren't membranes, and they were either going to have to haul offsite because they couldn't. Their other solution was hauling offsite, so that's what we were comparing ourselves against. And it's because they were facing regulatory pressure on soil and groundwater contamination. This is kind of near Green Bay, and they had a limit of how much nitrogen they could spread on the land. They can't spread in the winter, so they had to store it on their site. They would either have to store it on their site and spread it, or haul it off site when the nitrogen limit was reached that specific year. But they wanted a solution that was going to allow some sort of sustainability, so that's why they decided to go with the membranes, because they wanted to concentrate that nutrients. They recognized that the nutrients were valuable and that they didn't want to get rid of them and just kind of have them seep into the environment in a non-beneficial way. So the solution that they went with through, like I said, this was done through Digestate Organics. They went with a ZwitterCo SF plus RO solution. So when we did the economics with them, the hauling we expected to be reduced by 50% each year. So that was a significant OPEX number for them. And that's one of the reasons that they wanted to use the solution. They were able to meet discharge requirements. So they're putting over 100 million gallons per year of clean water into a stream nearby. And that stream had a relatively, I'm not sure the exact numbers off the top of my head, but their NIPDIS permit was relatively strict because the stream is dry part of the year. And then the other thing is that they were concentrating the ammonia-based, the second benefit is they're concentrating the ammonia-based nitrogen as a soluble organic liquid fertilizer. So they're doing it in two phases. The first phase was the membrane system, and then the second phase was taking the concentrate of the RO, and since it's a smaller stream in the concentrate, they were able to use a thermal process on that to concentrate the nitrogen and to make it a soluble product. The picture to the right, the ZwitterCo permeate. So this is the ZwitterCo permeate, and you can see that there's all the suspended solids are removed out of here, and it's mostly just the nutrients, salts, and nitrogen left in there. The RO permeates here. That's what's getting discharged into the stream. And then the concentrate is here. And this is what ZwitterCo is concentrating in there. They have some data from that study. This is the data from the field study. Unfortunately, I don't have the commercial case study yet. We're still working on that since it's been in operation for only 3 months now. But this is the data from the field study that confirmed the use of SF in the process. So this specific stream, the most important things is that we had a steady flux, 10 LMH for this digestate stream. We had a recovery of 95%. So 95% of the water going in is coming out in our permeate stream and going to the RO system. And we were able to get the permeants back up after each cleaning. So the gray bars here are cleaning. This is just a cleaning cycle with caustic, bleach, and there was also an acid in this cleaning cycle. The only time that we didn't clean, that we added a little bit of an anti-scalant was here, but we haven't really had any issues with that at the full commercial size. So this is some of the data that I like to show. It's most important is that it's steady operation. We're able to get back up to the full performance recovery, or full to the permeance that we wanted to be at, and this is one of the reasons why these membranes were used in the Digestate project. This is the last slide I have, but this is a little bit of, so we're just part of the process. We work with other integrators that develop the whole solution. We are just like a technology provider company. We have this membrane, we have a platform for membranes that we're using, and we're putting them into integrators' processes, and we work with them to develop that process with them. So this is a process, a little bit of an overview of the process that was used at BCO. So they had their solid liquid separation, and this is all the kind of byproducts that they're getting from each step that can be reused instead of wasted. So they get the fibers and bedding that they're recycling back to where the cows are situated in their farms, and they're giving those back to the farms. Then there's pre-treatment to the superfiltration in this case, and then there's at the pretreatment, any of the remaining phosphorus in the stream is going to come out. The phosphorus is usually connected to the larger solids that comes out way before a membrane system. So it's either going to come out in the solid liquid separation phase or the pretreatment to the membranes. And the superfiltration is getting out all the remaining solids that can impact the RO and the macropholates. And then the RO is going to take that stream and just concentrate potassium, nitrogen, salts, and then you can create a fertilizer out of that. And then the clean water is either recycled back to the farm, or in this case, it's being discharged into the river stream. So that's all I had for you today. I figured there'd be some questions so we can have a discussion about membranes, or we can have a discussion about any other trends that you see in digestate treatment and other technologies as well. So,
all right, I'm going to stop your screen sharing there. And there were some questions that came in.
Okay.
Steve, I'm going to just have you ask your question on mic and ask your question directly out. But here's a good one. Hang on, why can't I get there? This is a really good question. What do you do with the solids that come out of the microfiltration?
The microfiltration, or the ZwitterCo, you mean? Or the...
Well, yeah, it looks like it came out in your process from the superfiltration.
The solids that come out of our process depends on the digestate stream. Sometimes people are recycling them back to front of the digester, front of the process.
Okay.
Sometimes people are mixing it with the RO concentrate to see if they can get a valuable byproduct out of that. So it depends. We can do a nutrient analysis on each. We could do a nutrient analysis on the concentrate stream and decide from there. So it's dependent on the project, and there's a few different options that people are using. But
typically, you're looking to valorize it. You're looking for useful end products and not landfilling it.
No, yeah, we have not put our concentrate into a landfill. We're figuring out something to do in the process that's going to prevent it from being hauled outside to a landfill.
So what kinds of things do you know what they're are they using it on site?
Yeah, I mean, they'll either recycle, if they're gonna mix it with the RO concentrate and get the nutrient product out of it, then that'll be evaporated eventually, and then the nutrient product will be made there. So then the water is going to be removed there. If they're recycling it back into if the people see a usefulness in recycling it back to the front of the digester to try to valorize some more of those solids, then they'll do that as well. Those are the two most common that I've seen so far.
Cool. Steve, did you want to ask your last question?
Yeah,
it's just easier.
Yeah, and like, what kind of recoveries are you getting on ammonia and TKN, as well as total phosphorus? And can you use it for total phosphorus removal, including, like polyphosphates, things like that are more soluble given the cutoffs?
But are you asking about then the soluble phosphorus? And
yeah, like organic, non-reactive.
Mm-hmm. So all of that, the soluble material, we have a 1 kilodalton molecular weight cutoff as of now. So the those soluble material is going to pass through the membrane. So we don't typically we sometimes get modest rejection on like organic nitrogen, and that's because it's connected to the proteins that are a little bit bigger. But when the benefit of us is that all that stuff, that's pretty much going to be the only stuff that comes through the membrane. So that's going to be concentrated in the RO.
Okay. So the ammonia, you're not recovering ammonia through your membrane. It's going on through to the RO. And
yes.
Okay.
Yeah,
you're facilitating the recovery of it. Can we say that?
Sorry, what did you say?
You're facilitating the recovery of
yes,
that.
We're enabling that RO to allow to recover the ammonia. I know that there was through the whole process, there's 100% of the nitrogen that's going to be starting at the starting point. the whole process can recover 65% of the nitrogen.
Yeah. Yeah, I mean, just with digestate, pretty much everything coming out of a digester is going to be ammonia. So for the most part. So it's going to go on through. So you got to catch it based on the RO.
Mhm.
I'm not, and again, the only reason I'm asking is an alternative to say stripping, scrubbing in order to make fertilizer solutions.
Yeah.
So Brendan, do you see some potential to use this super filter in biosolids anaerobic digestion at all?
In the municipal world, you mean?
As we go towards water reuse applications, I mean, there's a lot more manure out there than biosolids, so I'm glad you started with that. But I'm just curious if you see any.
I mean, we see potential in it. We haven't done any projects in the municipal market yet, but we've done some testing with sewer separated organics. Not the municipal biosolids, but more just food waste sewer separated organics.
Yep.
And that has looked promising. So we're not, we haven't.
Well, that's good. There's a lot of that out there too.
Yes, but we haven't done any projects with the municipal biosolids yet.
Oh, fair enough. That's a tough one.
Yeah.
Any other questions? I know Jose was asking about the why there are problems finding. Where was that question?
Yeah.
Yeah.
I mean,
Why people don't know what to. It's probably a combination of different state regulations, and
there are certain states right now that have more regulations than others. It also depends on the soil type. I know, like Idaho, for example, the soil layer is only like 6 inches. So in that state, they're more concerned about salts getting stuck below the soil layer. And then it just accumulates over time. So then there's more regulations in that state on that. So they have to do something with the salt, get the salts out there. Then in like other states like Wisconsin and Michigan, they can't spread in the winter. So that's a hindrance. So these large manure digesters are huge, especially in the US. So they don't have anywhere to store that digestate. So that's the hindrance there, and why people are don't know what to do with the digestate there. And then in those states as well, they're getting hit with more nitrogen regulations. So they either have to haul it to a field that can accept the nitrogen load, or they have to treat the digestate there. So it's a mixture of a lot of different combos, and it depends on the location of where you are. But yeah, I would say it's more regulation.
Driven by regulation.
More regulation than not.
All right. I think I got all the questions in the chat. Anyone else have any questions for this? We've had presentations by your partner there, Digested Organics as well. I think we should get you both back again, maybe next year, to talk about one of your I think you got something going on in Massachusetts, right? Are you working on something?
Not in Massachusetts right now. We do have some other projects going on, so it would be cool once we get a commercial case study with the two of us. That could be an option.
Yeah, I would really enjoy that. Oh, you're welcome, Mo. Anyone else have any questions? I don't want to force you. This is a okay. Another question about the end products. Can you recycle all of it, or what do you do with the try to use as much as possible?
Yeah, I mean, some places like Michigan, they have a lot of stuff where they're doing like zero liquid discharge. So that's a tough one. We haven't done a project there yet, but that would be recycling. That would be trying to recycle all of it.
You up for that challenge? Yeah.
Yeah, I mean, the biggest thing is we're trying to reduce the offsite hauling of, like at BCO, we estimate that it's going to be about 50% reduction. So there's still going to be some like solid digestate that's going to be not used, but not used as much.
Right.
But it's going to be a lot less than it was before. So say
So yeah,
50 to
just
60.
reducing the volume is huge. It does really pay for itself.
We would like to recycle all the beneficial products out of it. I mean, that's the way of the future. So we have to reuse the valuable byproducts. And if you look towards like other places, especially like Europe, they're already trying to do all of that. So
Speaking of which, that's where you're
Yeah.
presenting from, right?
it's currently
You
where
guys got some work going on in Europe?
yes. Yeah.
Great. Yeah, that seems you'll have better luck there, I think. Getting going.
It's getting close in the US. There's a lot of stuff happening. So
Well, I'm glad that you guys are right on the cutting edge of this and involved in these projects.
yeah,
And
thanks for letting us present today too.
Brendan, this is
Yeah.
Stephen. Have you done anything with blood, animal blood separation on trying to harvest additional nitrogen out of the serum?
Animal blood separation, like plasma concentration.
Yeah, like the
stuff
plasma fraction.
Yeah,
Wow.
that is a very good question. And I personally haven't done that at ZwitterCo, but I know my colleague has looked into it. So I can ask him about it. And you also, there's two questions you wanted to know. You wanted to know about the struvite and animal. So I can get back to you specifically on those two.
Yeah, and I mean, our firm, we work, in digesters, but, some food waste. That's like the DAF skimmings.
Yep.
Coming off, most food plants have a DAF and, so it's handling those materials, but we also do a tremendous amount of work on rendering, and the more nitrogen, the more protein that we can recover in some of this wastewater, let it back into the feed would be beneficial. So if you take the stick, like typical now with blood, you recover the blood solids, you produce blood meals, but the serum is generally wasted to the wastewater. And if we could treat that serum water, recover that protein in that would add additional protein back into the feed.
Mm-hmm. Yeah, and one of our other bigger markets is working in poultry wastewater processing plants, meat wastewater processing plants, rendering wastewater processing plants. So I don't know specifically about the blood in those cases, but a lot of times, like you mentioned, all those plants have DAFs. Not everyone necessarily loves their DAF. They're trying to find alternatives to those DAFs.
Fair enough. Fair enough.
Yeah, and this, I mean, if you could take it off the chillers or whatever, off the internal recycle loops, I mean, that's a lot higher. That minimize how much DAF you got to deal with.
Yeah, and that's something we've looked into, is reducing DAF sizes with the membranes, because our membranes are like specifically good for fats, oils, and greases. So those streams have a lot of fats, oils, and greases. And
any information you got in that regard?
Yeah, I can send you some information over on some of the meat and poultry processing work we've been doing.
Okay.
I like how you guys think. All right. And any other questions for Brendan? It's almost dinner time there in Spain.
I think they eat at like 10 p.m., but yeah.
We'll have fun with that. Anyway, thanks so much for doing this, Brendan. I think this is really important technology you got here, and I look forward to seeing where it goes.
Yeah, thanks for hosting this.
Yeah, we're going to get you back with your partner, Digested Organics, in the future and have another great presentation.
I usually go to all the roundtables whenever the other discussions too. So
yeah, and so next month we have UConn's coming back. Professor McCutcheon's going to talk to us about that SCADA system they're trying to build to maximize biogas production there and anaerobic digesters. And if anyone has any other suggestions or something you really like to hear about or talk about at one of these roundtables, just let me know. But thank you, Brendan, so much for joining us today, and have a great weekend, everyone. Thanks for joining us.
Thanks, Janine. Have a good weekend.
You too. Bye, everyone.